Today we're going to demonstrate how to properly check for a battery draw on a motorcycle. Now we're going to use the R12GS for our test today. However, keep in mind that this procedure is the same regardless of whether or not you're working on a new technology motorcycle with CAN bus technology or you're working with an older product that has a conventional electrical system. Before we get started though, let's cover a couple of tools you're going to need to do this. One is using a shot multimeter. It's the easiest and quickest way to check for a draw on your motorcycle battery compared to hooking up your GT1. So we're just going to use a regular typical shot multimeter that you can find through Snap-on or any other tool manufacturer. And the second thing you'll need is a jumper wire. Simply a 2.5 millimeter gauge wire with two alligator clips on either end. And this is going to be used to connect the battery ground to your ground cable. And we'll demonstrate to you how to properly attach this cable. But before we get started, let's take a moment and look at the multimeter and describe to you which settings you're going to have to choose to correctly measure your battery draw. Now we'll just briefly touch on the different settings and receptacles that are on the multimeter, just so your general knowledge. Starting on the bottom, you have your receptacles for your two leads that you're going to use to measure your electrical measurements. The black lead is always going to be your ground, and the black lead is always going to be placed in the COM receptacle, regardless of what you're measuring, whether it's volts, amps, or ohms. It's always going to be in the COM receptacle. The red lead is going to vary between the remaining receptacles, and depending upon what type of measurement you want to have. The receptacle over here that I'm pointing to now would be used if you're measuring volts, ohms, or if you're measuring or testing a diode. Moving on to the other side of the multimeter is your receptacle if you're going to be measuring milliamps or microamps. And next to that is your receptacle for measuring amps. Now keep in mind that the two receptacles that are used to measure amps, there's a fuse inside the multimeter for these two sets of receptacles. And you have to be careful that whatever you're measuring is not greater than the fuse that's inside the multimeter. If that is the case, you're going to, one, blow that fuse, and two, you run the risk of potentially damaging your multimeter. For example, if you're measuring amps, this particular multimeter, you can measure up to 10 amps safely. Above 10 amps, you can see right here, 10 amps max fused, you're going to blow that fuse and run the risk of damaging the multimeter. With the the milliamp receptacle, there's a 500 milliamp fuse inside. So you can measure up to 500 milliamps, or anything above that, you're going to blow this fuse and possibly risk damaging your multimeter. However, don't use the 500 milliamps as the maximum. Always check your multimeter's owner's manual for the maximum amp rating that your tool was designed for. Because even though it may have a fuse for 500 milliamps, it may only be safe up to amount, say like 330 milliamps or 400 milliamps. 500 milliamps, for example, could be a safety net. So always check your owner's manual of the multimeter tool that you're using to find the maximum amperage that it can withstand. If you happen to take some measurements of amps and you're not getting anything displayed, always check the fuse first to make sure you have a good fuse in your tool. So those are the four receptacles on the bottom. Moving up on the dial here, you have different settings that you can choose depending upon what type of measurements you want to have. For example, here we have 10 amps. So if you want to measure a circuit for amperage, as long as that circuit is producing less than 10 amps, you would select a 10 amp circuit. Moving up, you have your milliamps. So if you're measuring a circuit that has very, very low amperage, you're going to be using the milliamps. We're going to be using the milliamps for testing our battery draw, because most of the time the amount of draw that's on your battery is going to be in the milliamp range. And we'll discuss that a little bit later on. Moving up is your microamps, and all three of these are direct current. So you have your direct current amperage, direct current milliamps, and direct current microamps. Moving on is your voltage. Everyone probably recognizes the V as voltage, and this is going to be your direct current voltage, and we know that by the solid line with the dotted line underneath it, meaning direct current. Next to that is another voltage measurement. However, that's going to be your alternating current voltage. And then we see again the microamps, the milliamps, and the amperage values again, and this is for your alternating current measurements. And then we have our diode check setting, and last is our ohm or resistance check. So those are the settings you can measure, and in the future we'll have more electronic videos describing each of these settings and how to measure them properly. But today we're going to focus on measuring a battery draw on our R12GS, and for that we're going to be using the milliamp settings. But one thing you want to do before you switch to milliamps is always check the draw first in amperage. So you always want to check it using the 10 amp value first. Once you have confidently recognized that the draw on the battery is low enough and it's not going to damage your multimeter, then you can switch to your milliamps and get an accurate measurement. If you go directly to milliamps and that draw happens to be much greater than that 500 milliamp fuse rating in our multimeter tool, you're going to blow that fuse. So always check in amperage, determine what size amperage draw you're making, and then you can drop down to a smaller caliber measurement, in this case milliamps, and measure the draw accurately. So now let's go through the process of hooking up our multimeter tool to the battery and measure our draw.